My name is PaigeDadika, and my study is the ontogeny of lateralized responses in the zebrafinch, time course, and the effect of atypical acoustic environments. The zebrafinch is a species of songbird that's utilized as a model of vocal learning in humans. This is because the two share many similar processes, which includes a developmental phase with a critical period. During this critical period, a zebrafinch must hear vocalizations from a tutor bird, typically its father, in order to build a template to base its own song off of. It has been shown that under this normative exposure period, zebrafinches begin to develop a right bias lateralization in a higher auditory area known as the caudomedial nidopallium, or the NCM. However, little is known about the necessary conditions and the onset of this right bias lateralization. And so the goal of the study is to answer the following questions. Would lateralized activity be detected if a developing zebrafinch lacks a direct tutor? As well as, if the zebrafinches are raised in a complex acoustic environment that is one of a different species, would this be sufficient to drive typical lateralization patterns? In order to test this, zebrafinches were implanted with an epidural ray at 40 days post-hatch and placed into one of three environments. The first, the explicit group, underwent typical tutor exposure. The second, the implicit group, listened to a conspecific acoustic environment, which consisted of zebrafinch aviary recording. The third group, the heterospecific group, consisted of a canary aviary recording. Throughout the study, the zebrafinches underwent 20 recording sessions where their brain activity was tracked in response to zebrafinch stimuli. The event-related potentials that resulted were measured using a peak-to-peak distance, where the bottom peak was subtracted from the top to determine an overall magnitude. The differences between the hemispheres were tracked using a lateralization index, with a positive lateralization index indicating a right bias. Figures A, B, and C show the individual groups throughout the study, and they all follow the general trend of beginning with a left bias at around day 40 and ending on day 20 with a right bias. Figure D is the group collapsed average, so it shows the average of every bird on a given day throughout their progression in the study. There is a fairly stable left bias from day 40 until around day 80 when there is a switch and the right bias lateralization begins. Additionally, throughout the study, we sampled the birds' songs throughout the day to see if there's any potential relationship between song crystallization and the onset of typical lateralization. It has been shown, as per the figure, that there is a stabilization of song at around the same time that this right bias lateralization begins to take effect. This study has two main limitations, one of which is the lack of a non-complex auditory environment, and the second is the bird's ability to self-vocalize. Hearing their self-vocalizations may be enough to drive typical lateralization patterns in and of itself, but this requires further research.